Welcome to the deep dive.
Yeah.
Ever feel like you're just drowning in information and you just need someone to point out the hidden treasures?
Mm-hmm.
That's what we do here. We take a stack of sources and we extract the golden nuggets of knowledge.
That's right.
Today we are diving into a topic that you might think you know.
Okay.
Printers.
Oh, yeah.
But trust me, there is a whole lot more to these everyday machines than meets the eye.
Absolutely. We will uncover how different types of printers actually work.
Right.
The mechanics, the materials, the magic behind those crisp pages, or even three-dimensional objects.
Yeah.
Plus, we'll explore why these differences matter to you.
Right.
What are the trade-offs when choosing a printer? Get ready for some surprising facts along the way.
Yeah, some real interesting stuff. Okay, let's start with the coolest stuff.
Oh, right.
3D printing.
Okay.
These things build objects layer by layer, almost like magic, right?
They do.
But how do they actually pull that off?
Yeah, it really is amazing when you think about it. 3D printing, also called additive manufacturing, is revolutionary because it builds objects from the ground up instead of carving away material like traditional methods.
Like sculpting.
Exactly, yeah.
It's almost like a super precise hot glue gun,
Uh-huh.
melting plastic to create each layer.
That's a great way to visualize it. The most common type, filament printing, or FDM, does work that way, but there's also resin printing, or SLA, which uses light to harden a liquid, almost like a high-tech sculptor working with liquid plastic.
Resin printing, that's how they get those incredibly detailed figures and models I've seen. Right?
Exactly. But you do have to be careful with the resin, as it can be hazardous.
Right.
Interestingly, they even have 3D printers on the International Space Station.
Wait, seriously? 3D printers in space?
It's true. Having a 3D printer on the ISS is a huge step towards self-sufficiency in space.
Wow.
Instead of waiting months for parts to be shipped from Earth, astronauts can print them on demand.
Wow, I never even considered that. What would you create with this tech if you had a 3D printer? A custom coffee cup holder for zero gravity.
Now there's an idea, but no matter what you're printing, both filament and resin printing rely on something called a print bed.
The print bed. Is that like the foundation for the 3D object?
Precisely. It's a flat surface where the object is built layer by layer. The bed often needs to be heated and sometimes has a special adhesive to make sure the object sticks properly.
Oh, interesting. So it's got to be perfectly level and clean to avoid a leaning tower of plastic.
Okay, we've seen the future of printing, but let's jump back in time to the technology that paved the way: impact printers.
Yeah.
Those old school workhorses, what made them so special?
Impact printers. Think of those noisy dot matrix printers you might have seen in old movies.
Yeah.
While they aren't fancy, they were incredibly durable and could handle tasks that modern printers can't, like making multiple carbon copies at once.
I bet they were loud, though. Did they even produce high-resolution graphics? Not exactly known for their stunning visuals.
Right.
They literally smashed ink onto paper using a matrix of pins, creating that iconic dot matrix look. It was a symphony of noise, but very effective for its time.
I vaguely remember those continuous sheets of green bar paper they used. What a blast from the past.
Yeah.
What modern tech do you think will still be around decades from now? Like those old impact printers.
That's an intriguing question, perhaps something we haven't even thought of yet.
Right.
But now let's talk about the printer that most people are familiar with today, the inkjet, a staple of home offices everywhere.
Inkjets. Affordable and convenient, but I swear those ink cartridges run out faster than a phone battery. Plus, there's always that dreaded clogging issue.
You're not wrong. Inkjets are surprisingly complex considering how commonplace they are.
Right.
Tiny droplets of ink are sprayed onto the paper, creating high-resolution images, but those tiny nozzles can clog, leading to streaks or missing colors.
Ugh, the worst. And don't even get me started on paper jams.
Those are frustrating. Paper jams are a printer owner's nightmare. They usually happen when the paper doesn't feed smoothly through the printer, often caused by dust buildup or crumpled edges.
So keeping things clean is crucial for smooth operation. Speaking of smooth operation, I've always wondered, what makes it possible to print on both sides of a page?
Yeah.
Is there like a secret double-sided paper?
Not quite. That feature is called duplexing, and it's become quite common in modern printers. It basically involves flipping the paper internally so it can print on both sides.
Okay.
And remember those alignment pages that inkjets make you print?
Yes.
Those are for calibration.
Calibration. Like making sure the colors are all lined up correctly.
Precisely. It's like fine-tuning a musical instrument to ensure all the colors are in harmony, creating a beautiful, clear print. Speaking of print quality, let's talk about those speed demons of the printing world. Laser printers. They use static electricity and lasers to create those crisp, professional-looking pages. How cool is that? Laser printers are a marvel of engineering. It's a 7-step process, starting with the laser writing the image onto a photosensitive drum.
Okay.
Toner, which is like a fine powder, sticks to those areas and is then transferred to the paper using heat and pressure. It's like a tiny factory inside that machine.
No wonder those pages come out so warm.
That warmth comes from the fuser unit, which melts the toner onto the paper, creating a permanent bond.
Okay.
And speaking of heat, be careful when doing any maintenance on a laser printer, as that fuser can get extremely hot.
Good to know. Laser printers sound like a whole different beast compared to inkjets. But let's not forget about the multi-talented members of the printer family multifunction devices, or MFDs.
Right.
They can print, scan, copy. Sometimes they feel like they can do it all.
MFDs have become essential for modern offices, haven't they?
Yeah.
They streamline workflows and consolidate multiple devices into one space-saving unit.
Yeah.
Plus, they can connect to your network, allowing everyone to share them.
Sharing is caring, right?
Yeah.
But setting up an MFD can seem intimidating with all the networking, drivers, and security settings.
It can seem that way, but it's actually pretty straightforward once you understand the basics. One important thing to remember is that MFDs use printer languages like PCL and PostScript, which tell the printer how to understand and print the data.
Right.
Of course, having the correct drivers for your computer is also key.
Right, those drivers are crucial. And what about all those different connectors on the back of an MFD? There's always so many.
Those are for all the different ways your MFD can connect to your devices and network. You've got USB for direct connections, Ethernet for wired networks, and often wireless options like Wi-Fi too.
Okay.
You can even set up printer shares in Windows so everyone on your network can access it.
That makes sense. So whether you're printing from your laptop, your phone, or even that ancient desktop in the corner, everyone can get their printing done.
Exactly. And for larger offices, there's something called a print server that helps manage everything, queuing jobs efficiently, and eliminating the need for everyone to rely on one person's computer being on to print.
Print servers sound like the unsung heroes of office productivity. But it's not just about connectivity, and sharing security is also super important, especially for sensitive documents.
Absolutely. Thankfully, MFDs come with various security features like password protection and audit logs that track who printed what and when.
Oh, nice.
You can even set up secure printing with pins to protect confidential documents.
Oh, wow.
Plus, there's usually a built-in scanner that can turn your paper documents into digital files.
It's like having a mini digital archive right at your fingertips.
It is.
MFDs really have transformed the way we work with documents. Now, for our final stop on this printing technology tour, let's look at a device that's often overlooked, but plays a critical role in many everyday situations, the thermal printer.
Thermal printers are those quiet workhorses that give us receipts at stores, print shipping labels, and even power those old-school fax machines.
They're incredibly quiet compared to other printers, and they print so quickly. What's the secret behind their speed and silence?
Their secret is that they work completely differently than impact or inkjet printers.
Right.
No ink, no toner involved.
Wow.
Thermal printers rely on a special type of paper that's heat sensitive. It changes color when exposed to heat.
So no messy cartridges to replace. That's pretty neat.
Exactly. The paper is coated with microscopic dye capsules that burst open when heated, releasing the dye and creating the image.
Fascinating. It's like a high-tech version of those color-changing mugs.
It is.
But if the paper is reacting to heat, how does the printer create the image so precisely?
The print head contains a row of tiny heating elements that are individually controlled.
Okay.
As the paper moves past, the heating elements activate, selectively heating specific areas and creating the desired image.
So it's like a miniature, super precise branding iron, creating an image on the paper with heat.
A great way to visualize it.
But earlier we talked about how thermal paper can fade over time. Does that make it unsuitable for certain things?
That's true. While thermal paper is perfect for things like receipts, tickets, and shipping labels where the information is temporary, it's not ideal for long-term archiving because it can fade over time.
Okay, that makes sense. Well, we've covered a lot of ground today, from the futuristic 3D printers to the humble but mighty thermal printer. Hopefully you now have a deeper understanding of the inner workings of these everyday machines.
Yeah, they're pretty amazing.
They are.
And there's a lot more to talk about.
Absolutely. And we are not done yet.
That's right.
Stay tuned for part 2, where we'll delve even deeper into the mechanics and hidden complexities of these amazing printing technologies.
We will.
All right. We'll see you then.
Welcome back to the deep dive. Last time we explored different types of printers, but now it's time to, roll up our sleeves and get a little more hands-on with the inner workings of these fascinating machines.
I'm ready to get inky. Where do we start?
Let's revisit those iconic impact printers, those dot matrix machines you might remember from your early computing
Oh,
days.
yeah.
Those tiny pins hammering away at the ribbon. It was a symphony of noise, but there was a lot of clever engineering going on behind the scenes.
It always seemed like a pretty brute force approach to me.
Mm.
Just smash ink onto the paper and hope for the best.
You're not wrong. There was a certain rugged simplicity to them. Dot matrix printers worked on a purely mechanical principle. The print head had a grid of tiny pins, and when those pins were activated by electromagnets, they would strike the ribbon, transferring the ink to the paper.
So it's kind of like a miniature typewriter. Except instead of individual keys, you have this grid of pins creating each character.
That's a great analogy, and the spacing and timing of those pin strikes determine the shape of each character, producing legible text even if it had that distinct dot matrix look.
And those printers were built to last.
They were.
They could handle continuous feed paper, carbon copies, and even those thick multi-part forms that seemed to be everywhere back then.
They were definitely workhorses. The go-to solution when you needed durability and reliability, especially in environments that would be tough on more delicate printers. Think about warehouses, factories, places where dust or extreme temperatures could be an issue.
It's amazing how some technologies just stick around because they're so good at what they do. Now fast forward a few decades, and let's talk about the inkjet printer.
Okay.
The trusty workhorse in homes and small offices around the world. It's pretty incredible how sophisticated these printers have become, especially considering their price.
They really have come a long way. Modern inkjet printers produce vibrant, high-resolution images and text that can rival laser printers in terms of quality.
Yeah, I remember the early inkjets, they sounded like a swarm of angry bees,
Yeah.
and the print quality wasn't exactly award-winning.
Yes, technology marches on. Inkjet printers have benefited from huge advances in microfluidics, the science of manipulating tiny amounts of fluids, and precision engineering. The print heads in modern inkjets contain hundreds, sometimes thousands, of microscopic nozzles that eject ink droplets with incredible accuracy.
Wow, thousands of tiny nozzles in one print head. That's mind-blowing.
Yeah.
But how do those tiny drops of ink actually get onto the paper?
There are two main methods. Thermal inkjet printers use heat to vaporize the ink, creating a bubble that propels the droplet onto the paper. Piezoelectric inkjet printers, on the other hand, use a special crystal that vibrates when an electric current is applied, pushing the ink out.
It sounds like we're talking about some seriously tiny movements and forces here. But all those little droplets add up to create the images we see, right?
That's right. And the precision of those ink placements is critical. Each droplet must land exactly where it's supposed to, or you end up with blurry images or fuzzy text.
Right, and let's not forget about color. Inkjet printers use that CMYK color model, cyan, magenta, yellow, and black, to create a full spectrum of colors.
Yes.
It's fascinating how those four colors can be combined to create almost any shade you can imagine.
It really is. By mixing those four primary colors in precise ratios, inkjet printers can reproduce an amazing range of hues and tones. It's a testament to the power of both physics and chemistry working together.
Speaking of working together, let's talk about keeping those little inkjets happy and printing smoothly. I feel like I'm constantly battling paper jams and clogged print heads. Any tips for a struggling printer owner?
Yes, the joys of inkjet maintenance. Regular cleaning is essential, both for the print heads and the paper feed mechanism. Most inkjets have built-in cleaning cycles you can run, but sometimes you need to get a little more hands-on.
Like when you open up the printer and find a graveyard of crumpled paper and dried ink?
Exactly. A gentle swab with some isopropyl alcohol and a cotton swab can work wonders on those stubborn clogs. And don't forget about those feed rollers that pull the paper through. They can accumulate dust and debris, which can lead to jams. A quick wipe down with a lint-free cloth can help keep things running smoothly.
It's all about preventative maintenance, just like with a car. But what about the paper itself? Does the type of paper matter when it comes to inkjet printing?
It absolutely does. Using paper that's too thin or too absorbent can lead to ink bleeding through or smearing.
Right.
And those economy ink cartridges that promise the world, sometimes it's worth spending a little extra for quality ink that won't fade or clog your printer.
Good to know. Quality over quantity, especially when it comes to those ink cartridges. Now let's shift gears and talk about those sleek and speedy laser printers, the workhorses you find in large offices and professional print shops. They use a completely different technology than inkjets, relying on static electricity and lasers to do their magic.
Laser printers are fascinating machines, aren't they?
Yeah,
They're like miniature photocopiers, using a complex process to fuse toner onto the paper.
and they're fast. I've seen those things churn out pages faster than I can read them. But let's break down how that printing process actually works.
Sure. It all starts with a photosensitive drum, a key component inside the laser printer. This drum has a special coating that reacts to light and is given a static electric charge at the beginning of the printing process.
So it's like a blank canvas waiting for the laser to paint the image onto it.
Exactly. The laser beam scans across the drum, selectively discharging certain areas, which creates an electrostatic image of the page to be printed. Next, toner, a fine powder, is attracted to those discharged areas, adhering to the drum in the exact pattern of the image.
It's like those iron filings that arrange themselves along magnetic field lines, except in this case, it's toner clinging to the electrostatic pattern created by the laser.
What a great analogy. Then, the toner-coated drum comes into contact with the paper, which has also been given an opposite static charge, and the toner is transferred. The final step is the fusing process.
Which is why those freshly printed pages come out all warm and toasty.
Exactly. The fuser unit uses heat and pressure to melt that toner onto the paper, creating a permanent bond. That's how laser printers achieve those crisp, high-quality prints they're known for. It's a pretty amazing process when you think about all the steps involved.
It really is. But as with any complex machine, I imagine things can go wrong. What are some common issues laser printer owners might run into?
Well, just like with inkjets, paper jams are always a possibility. And because laser printers have more moving parts and higher temperatures, there's a bit more potential for things to go awry. For example, the fuser unit can wear out over time, leading to faded prints or even more paper jams. And toner cartridges can be a little messy to replace if you're not careful.
I bet. That toner powder seems like it could get everywhere.
It's definitely fine, can become airborne easily. So, handle those toner cartridges with care. But the good news is that laser printers tend to be more efficient with toner usage than inkjets are with ink, so you won't be replacing those cartridges quite as often.
That's good to hear.
Yeah.
I can't imagine having to swap out toner cartridges as often as I replace ink in my inkjet. Now, you mentioned color laser printing earlier. How do they manage to combine all those different colored toners to create a full color image?
It's pretty ingenious, actually. Color laser printers have separate toner cartridges for each of the CMYK colors: cyan, magenta, yellow, and black. The printing process involves multiple passes, with the paper moving past each toner station in turn. The laser applies each color to the drum, and then those colors are layered on top of each other on the paper.
So it's kind of like those layered color transparencies we used in school to learn about mixing colors, except this is happening at a microscopic level and at super speed.
Exactly. And just like with inkjet printers, the precision of those toner placements is crucial for getting accurate color reproduction. Any misalignment or uneven toner application can result in blurry images or strange color fringing.
It's incredible how much precision is involved in something as seemingly simple as printing a document. Now, we've talked about the environmental impact of ink cartridges, but what about those toner cartridges from laser printers? I imagine they have similar concerns.
You're absolutely right. Responsible disposal of toner cartridges is just as important as with ink cartridges. Toner cartridges contain plastics and other materials that shouldn't end up in landfills. Thankfully, a lot of manufacturers have recycling programs, and there are also third-party companies that specialize in cartridge recycling.
That's great to hear. So, whether you're Team Inkjet or Team Laser, there are ways to be mindful of the environmental impact. Now, let's talk about a type of printer that doesn't get as much attention, but is a real workhorse in a lot of industries: the thermal printer.
Thermal printers really are the unsung heroes of the printing world. They give us those receipts at the grocery store, print shipping labels, and are even found in those old-school fax machines that are still hanging on in some places.
They're amazingly quiet compared to other types of printers, and they seem to print almost instantaneously. What's the secret behind their speed and silence?
Their secret is that they work completely differently than impact or inkjet printers. No ink, no toner involved. Thermal printers rely on a special type of paper that's heat sensitive. It changes color when exposed to heat.
That's so cool. No messy cartridges to replace.
Right.
But how does the printer create the image on the paper if there's no ink involved?
The magic is in that heat-sensitive paper. It's coated with a layer that contains tiny dye capsules. At room temperature, these capsules are colorless, but when you apply heat, they burst open, releasing the dye and creating a dark mark on the paper.
So it's a chemical reaction triggered by heat. That's fascinating.
It is. And the printer controls exactly where that heat is applied using a print head that contains a row of tiny heating elements. These elements are carefully arranged to match the printer's resolution. As the paper moves past the print head, the heating elements are activated, selectively heating specific areas and creating the desired image.
So it's like a miniature high-tech branding iron, creating an image on the paper with heat.
A great way to visualize it. And because there's no ink or toner, thermal printing is incredibly quiet and efficient. It's almost instantaneous, and no messy cartridges to worry about.
But earlier we talked about thermal paper fading over time. So it's not a good choice for everything, right?
That's right. Thermal paper isn't ideal for anything you need to keep for a long time, like important documents or photos. It's perfect for receipts, tickets, and shipping labels where the information is temporary.
Okay, that makes sense. Well, we've taken a deep dive into the inner workings of impact, inkjet, laser, and thermal printers. It's amazing how diverse these technologies are, each with its own strengths and weaknesses.
It really highlights the incredible ingenuity of human invention. Printers have evolved from those basic mechanical devices to the sophisticated multifunctional machines we have today, and they play a vital role in our lives.
That's a great point. And we're not done yet. In Part 3, we'll explore some of the cutting-edge advancements in printing technology that are shaping the future. Stay tuned. Welcome back to the Deep Dive. We've explored the mechanics of so many different printers, from dot matrix to inkjet, from laser to thermal. But as amazing as those technologies are, we've barely scratched the surface. The world of printing is constantly evolving, pushing the boundaries of what's possible.
You're absolutely right. Remember those incredible 3D printers we talked about earlier?
Yeah.
They're not just a futuristic novelty anymore. They're rapidly transforming industries, from manufacturing to healthcare, and even pushing the limits of creativity in art and design.
It's mind-boggling to think that we can now print fully functional objects, layer by layer, just from a digital design. It seems like science fiction. But how is this technology actually being used in the real world today?
Well, in manufacturing, 3D printing, also known as additive manufacturing, is completely revolutionizing prototyping and production. Imagine being able to create complex parts on demand without needing expensive tooling or massive manufacturing facilities.
That's a game changer, especially for smaller businesses and entrepreneurs. It levels the playing field, allowing them to compete with larger companies when it comes to design and production capabilities.
Exactly. And in healthcare, 3D printing is being used to create custom prosthetics, implants, and even surgical guides.
Wow.
Surgeons can now practice complex procedures on 3D printed models of a patient's anatomy.
It's amazing how this technology can improve people's lives in such profound ways. But 3D printing isn't just about practical applications, is it? It's also sparking a creative revolution in art and design.
Absolutely. Artists and designers are using 3D printing to create intricate sculptures, jewelry, fashion accessories, you name it. They're making objects with unique and complex geometries that would be impossible to create using traditional methods.
It's like everyone has a personal fabrication lab right on their desktop. So much creative potential. But where do you see 3D printing going in the future? What kind of advancements are on the horizon?
One area that has everyone excited is bioprinting,
Bioprinting.
which uses 3D printing techniques to create living tissues and organs.
Really?
Imagine a future where we can print replacement organs on demand, eliminating the need for organ donors and those long waiting lists.
That would be revolutionary.
Yeah.
It almost seems too incredible to imagine, but knowing how rapidly technology is advancing, it might not be that far off. But let's not forget about the more traditional printing technologies. Inkjet and laser printers are still evolving too, right?
Absolutely. Inkjet and laser printing technologies are also advancing, becoming faster, more efficient, and more environmentally friendly. Manufacturers are continually improving ink and toner formulations to make them more durable, fade-resistant, and less prone to those dreaded clogs.
That's good to hear. And what about those multifunctional devices, the ones that can print, scan, copy, and even fax? It seems like they're constantly adding more features and becoming even more sophisticated.
You're right. Those multifunctional devices, or MFDs, are transforming the way we work with documents. They're streamlining workflows and reducing our reliance on separate devices by integrating so much functionality into one machine.
Right.
They're offering features like wireless connectivity, cloud integration, and advanced security options, which makes them even more versatile and powerful.
It's really amazing to think how far printing technology has come. from those early mechanical marvels to the high-tech wonders we have today. And the future looks even more exciting, with all the advancements in 3D printing, bioprinting, and who knows what else is just around the corner.
It truly is a testament to human ingenuity and our constant drive to push the limits of what's possible. It makes you wonder what incredible printing innovations we'll be talking about in the years to come.
Well, that brings us to the end of our deep dive into the world of printing technology. We've covered a lot of ground, from the history to the inner workings to the future possibilities of these amazing machines.
We hope you've enjoyed this journey through the fascinating world of printers.
And remember, the next time you hit that print button, take a moment to appreciate the intricate processes and technological marvels that make it all possible. Until next time, keep exploring, keep learning, and keep diving deep.